Hello everyone. Today's topic is nodal analysis. Before going for nodal analysis, first let us know what do you mean by a node. So node is nothing but the common point where two or more elements are connected is termed as a node. So let us take this particular circuit where we have connected two resistors. So the intersection point of these two resistors is this particular point. So this point is termed as node. But here as only two elements are connected, this particular node is known as a simple node. So when we have a simple node, if the current is flowing from this particular point, the current starts flowing from this resistor and the same current also flows through a resistor R2. Therefore, here the current division is not possible in simple node. Therefore, if we are connecting more than two elements, that is, this is R1, R2 and R3. So when we have connected three resistors, the intersection point of these three resistors is known as node. This node is known as principal node. So when we take a current I, the current I is divided into two parts as I1 and I2. Therefore, at a principal node, the current division is possible, whereas at simple node, the current division is not possible. Therefore, when we go for a nodal analysis, the nodal analysis is applicable when only for principal nodes, that is when current division is possible. Therefore, when I refer nodal analysis, the node implies a principal node. So, here when we are going to apply a nodal analysis is an application of Kirchhoff's current law, which is used for calculating the voltages at each node. So, when we are going for the analysis using nodal analysis, we have to follow the following procedure. So, the steps for the nodal analysis are, the first step is we need to identify the total number of nodes. Here node implies the principal nodes where more than two elements are connected. The second step is assign the voltage at each node. So once we identify the number of nodes, next we need to assign the voltages at each node. Out of all the nodes, one node is taken as reference node. So reference node implies here we take the voltage as 0 volts. We assume that the voltage at that particular node is equal to 0. Step 3. Develop the KCL equation for each non-reference node. For suppose if we consider 4 nodes present in the circuit, one node is taken as a reference node and its voltage is assigned to be equal to 0 volts. And the remaining 3 nodes are known as non-reference nodes, for which we are going to write the nodal equations. The fourth step is solve the KCL equations to get the nodal voltage. So once we get the equations, on solving those equations, we are going to get the nodal voltage, and depending upon the voltages obtained by the nodal analysis, we are going to find out the parameters which are given in your particular problem. So here let us consider, this is an example on nodal analysis. Here we need to find out the current flowing through 2 ohms resistor using nodal analysis, and the circuit given is, this is the circuit, and we need to find out the current flowing through 2 ohms resistor. So the first step in nodal analysis is we need to identify the node. And what is a node here? Here we need to find out a node at which there are more than two elements which are connected. So when you consider this point, here only two elements are connected. Therefore, we are not going to consider this simple node. And when we come for this point, here there is an intersection of three resistors. Therefore, this point should be taken as node 1. Here only two elements are connected. Therefore, we are not going to take it as a node. And when we come for this point, again three elements are connected, and let us take this node as 0. The second step is we have to take one node as reference node and assign the voltage to be equal to 0 volts. I am taking this node as reference node and I assign the value of voltage to be equal to 0. Third step, we need to assign the voltages and current directions at each node. So here we have only one node. Therefore, we need to assign the direction of currents as well as the voltages at that particular node. So let us take the value of voltage at this node is equal to V, and as the current source is given, first we need to assign the direction of the branch in which the current source is present. So here the direction of flow of current is from downward direction to upward direction. Therefore, this is the direction of flow of current. Let this be I1. And where the current sources are not present, those branches we have to assign the direction towards the reference node. Therefore, here it will be outwards your main node I2 and I3. So once the direction of currents are given, next we need to apply the KCL. So KCL refers to Kirchhoff's current law, and it states that the sum of the currents entering the node should be equal to sum of the currents leaving the node. Here the currents which are entering are I1 and currents that are leaving are I2 and I3. Therefore, I1 is directly given as 5 amperes. So 5 is equal to I2 plus I3. As the value of currents are not given, we are going to write the equation of current as I is equal to V by R. So what is the I2 current? The voltage at I2 is V1 and the resistance is 2 ohms. Therefore, we are going to write it as V1 by 2 plus I3. The voltage at node 3 is V1 and the resistance is 3 ohms. But in the same branch, we have another voltage source to be connected. Therefore, we are going to write the voltage as V1 minus the given voltage 12 by the resistance, that is 3. So 5 is equal to, if we take V1 as common, we can write this equation as V1 into 1 by 2 plus 1 by 3 close the bracket minus 12 by 3. So 5 is equal to V1 into, when we take LCM, that is 3 plus 2 by 6 minus 4. So 5 minus 4 is equal to V1 into 5 by 6. So 1 is equal to V1 When this comes on to the left hand side, it becomes 6 by 5. So V1 is equal to 6 by 5, that is equal to 1.2 volts. So here we are asked, here we need to find out the current flowing through 2 ohms resistor. Therefore, current flowing through current flowing through 2 ohms resistor is I2 is equal to V1 by 2, that is 1.2 by 2, that is equal to 0.6 amperes. So this is how we are going to find out the currents flowing through a resistor or an element by using nodal analysis. Thank you.